Hello everyone. In this video I will be focusing on class test 2, giving you feedback and pointers on the class test. You will notice that the questions that I will be doing are exactly the same as those that you had for your class test. So the idea is that you actually follow the same logic in reviewing your attempt of the class test. That way, seeing where you went wrong and actually improving on that. You may have also seen that the whole test was themed on procrastination, something that I believe that at some point in our lives we all have been guilty of. Now, before I go to the questions, allow me to put an emphasis on the importance of reading and understanding instructions. You will recall that for this test, the first question was you acknowledging that you've read and understood the instruction. Why is this important? It is important because I believe for STK 110, not only are you supposed to learn the contents of this module, but also in the process, your soft skills should develop, and one of which is being able to read, understand, and follow instruction in whatever assessment that you're doing. So I really appeal with you guys, please take note and actually follow your instructions. Now, for this test, the first question, we are given the following information. A study was conducted at one of the top universities in South Africa. In this study, the effect of procrastination on academic performance was investigated. Prior information shows that 33% of female students and 45% of male students leave submission of assignments to the last minute. That is, they procrastinate. A random sample of 150 female and 150 male students in the module XYZ111 will be used to estimate the proportion of male and female students who procrastinate. Now, we give you the standard error for the sample proportion of males and females who procrastinate. Now, question 1, we are asked, what is or are the necessary assumptions for the sampling distribution of P bar male, P bar female to be approximately normally distributed? This is a theoretical question that was covered in chapter 7, where we said for the sampling distribution of P bar to be approximately normally distributed, two conditions need to hold, and that is the number of successes and the number of failures should be greater than or equals to 5. So you should have at least 5 successes and at least 5 failures for you to have the sample proportion being approximately normally distributed. So in this case, that means the correct answer will be C. Because in C, you will see the number of successes is found by taking the sample size and multiplying it by the probability of success. And the number of failures is just nothing but taking the sample size and multiplying it by the probability of failure. So we can check these conditions for these two variables that we have for the males and for the females. Now, for the male, for the sample proportion of males to be approximately normally distributed, what does that mean? It means the number of successes of males, so it means the sample size of males times the probability of success for males. In this case, we have been told in the question that we take 150 males multiplied by the probability of success, or the probability of getting males that procrastinate, which is 0.45, and that gives us 67.5, which is clearly greater than 5. And then the number of failures in this case will be number of males that we take, 1 minus the probability of success, which in this case will be 150 times 0. 1 bracket, sorry, minus 0.45, and that answer will be equals to 82.5, and this is also greater than 5. So you will agree that with me that both conditions hold for the sample proportion of males. So we can say, since the number of successes and the number of failures for the male is greater than 5, then the sample proportion of male P bar M is approximately normally distributed. We can do the same thing for females, and then we can see that this is 150, and we are told that the probability, or rather the proportion of females who procrastinate is 33%, so 0.33, and that gives us 49.5, which is clearly greater than 5, and the number of failures is NF 1 minus PF, and which is 150 times 1 minus 0.33, and this will give us 100.5, and this is also greater than 5. So we will agree that since for both P bar M and P bar F the conditions hold, we can say they are approximately normally distributed, which brings us to question 2, which was asking us for the distribution thereof. So you either got the distribution of P bar F or P bar M, and we are agreeing that it is approximately normally distributed. Now the question is, what are the parameters? So you will recall in chapter 7 we said if we've got a P bar and it is approximately normally distributed, the parameters are the proportion and the variance, or sigma squared P bar. So the expected value is given as P, and now you will remember that the square of the standard error, or the variance of P bar, was given as P 1 minus P over N, and these are the parameters. Just always remember that we do not give it as a standard error. It's the standard error squared, the variance of P bar. So in this case, we will recall that for females, the expected value of P bar females is nothing but P of females, and we are given that in the question that it is equals to 0.33. And then here we are asked what is the standard error squared of P bar, and you will agree with me that this is nothing but, for the females, given to us as 0.03839, but this is the standard error, so we square it. That's what we gave you, because we give, for the parameters of a normal distribution, we give the expected value and the variance. So this, if you want to calculate it, you will see that it actually simplifies to 0.001474. Now, so that means, to answer this question, that means this is your A, this is your B. So you agree with me that that means the value of A is 0.33, and then the value of B, you could have just given it as 0.001474, or that is on ClickUp, given it as 0.0389 or 39, sorry, but most of you just left it like this and forgot to square it. That is why we say to the power 2, and remember that's how you type squared, or to the power of 2 on ClickUp. So we can do the same thing for male, and we know that for male the expected value of the proportion P bar male is nothing but P male, and in the question we have been given that this is 0.45, and then the standard error squared of P male, sorry, I needed to add this, P male is nothing but what we are given here as 0.04062, but we are not looking for the standard error but the variance of P bar male, so we square it, and this one can be written as 0.00165. All right, now with that being said, we can come and put our answers now as you would have put it on ClickUp. So on ClickUp you would have gone and written that your A is, maybe let's get a different color, your A is 0.45, and then your B is 0.00165, or some of you may have written it as 0.04062 to the power 2. Just remember that. All right, now that we have our distribution for the P bar female and P bar male, we can get any question, we can answer any question on probability on these two. So for the next question, we are asked, what is the probability that a sample proportion of male who procrastinate will be within 0.01 of the population proportion? Now, question is, what is the population proportion? The population proportion is 0.045. 0.45, sorry. So now they are saying what is the probability that it will be at a distance of 0.01. So in this case that it will be between 0.44 and 0.46. You will agree with me. Another way that you can view this is that you know if it's at this distance that they are actually asking you what is the probability that the sampling error will be within 0.01. But for this one, let us just do it like this. So the first thing that we've always emphasized on is that when you are asked to calculate a probability, the first step is that you will need to write the probability statement. In this case, you are being asked what is the probability that your sample proportion will be between 0.44 and 0.46. Now, when you are dealing with this, the next step is that you will need to standardize. And how you standardize this is you will need to calculate Z. And what is Z? So we'll come and put it in the middle. We know that Z is taking your P bar, subtracting the proportion and dividing by the standard error of P bar. In this case, we are dealing with male, so it's P bar male, male, male. So that's what I needed to write here. So now, what is that? You know that you are saying you're looking for 0.44 minus what is that? 0.45 all over the standard error of P bar male. So, and that is 0.04062. Same thing applies to here, 0.46 minus 0.45 divided by 0.04062. And you will see that this will simplify to the probability that Z is between negative 0.25 and 0.25. Now you'll agree with me why I say this is just exactly the same as finding the probability that the sampling area for the proportion of males, that is less than or equals to 0.01. So you could go and attempt it like this. Now, how do we do this? Now we have this. The best way to do it is to draw and represent what they are asking you. So we'll draw it just here because we don't have enough space, and you know Z is centered at 0, and you're looking for the area between 0.25 and negative 0.25, and that area shaded is nothing but you going to 0.25. You know, when you, because your Z gives you lower tail probability, when you go to negative or to 0.25, you get 0.25 going all the way down, and when you come to negative, you get negative going all the way down. But this is the piece that you are looking for. So what you will do is you will take this and subtract what you don't want. That is why this simplifies to the probability that Z is less than 0.25, which is this one going down, minus the probability that Z is less than negative 0.25, which is minus this one going down. Now you're only left with the piece you're looking for. So we go to 0.25, 0.25 in our tables, and we get 0.5987. Subtract going to negative 0.25, which is 0.4013. And the final answer that you get there is a 0.1974. As easy as that. I hope we are happy with that. Now we're going to go and see what question 4 is asking from us. So in question 4, they're saying the study on procrastination that we've been discussing was conducted at another university in South Africa. Now, for this study, a sample of 65 males was taken from the module ABC 111, and 52 of the males were found to procrastinate. Now they are saying you've got this P bar being the sample proportion of male students who procrastinate, and this P is the population proportion of male who procrastinate. Now you are asked to calculate the lower limit of the 80% confidence interval for the population proportion, which is the population proportion of males who procrastinate. Now, in this case, we are supposed to find A, B, C, and D. So how I would answer such question is I would go and write what is the formula for calculating a confidence interval for a proportion. And that formula, if you remember it very well, is for a proportion we use P bar plus minus Z alpha over 2. And then it's the standard error of P bar. But now we don't have the standard error of P, we don't have P, we have P bar. So otherwise the standard error would be the square root P 1 minus P over N. But we don't have P in this question, all we have is P bar. And since we know that P bar is the point estimator of P, yes, then we can use P bar to approximate or to estimate the standard error of P. So we remember that this is the formula of the standard error. And in this case, in this question, we are asked to find the lower limit. And the lower limit is us finding the minus, not the plus. So you will agree with me then that this will be your A. And now they are asking minus B times C. So this is your B, and then this is your C. So now it's time for us to do our rough work. You know that A is your P bar. A is equals to P bar. And what is your P bar sample proportion? You are told that 52 out of the 65 males procrastinate. So that means your P bar is 0.8. Now your B is your Z alpha over 2. Z alpha over 2. Z alpha over 2. Now we are told to calculate a 80% confidence interval. Now we know that if we are calculating as 80% confidence interval, our alpha is 1 minus the level of confidence. Ne? So this will be 1 minus 0.8. That means it's 0.2. That's your alpha. So alpha over 2 will be 0.1. So you are looking for Z of 0.1, right? And what is that value? So you go to your Z tables, you're given a probability of 0.1 and you're looking for a Z value. And while you are searching, you will see that the closest is this one. And now you will see, sorry about that, my numbers have disappeared here, I don't know how. And you will see that this one is 1.2 and there is an 0.9 here, 0.8 and so on because there is 0.0 here, point. So you will agree with me that this Z alpha over 2 is 1.28. So we will take it as 1.28. Now you will see it says negative 1.28, but because we are dealing with two-tail, we will take it like this because the negative will actually come in here because to calculate a confidence interval, we're doing plus minus. So it's both the negative 1.28 and 1.28. So now we come to C. What is C? We've said that C is our estimate for the standard error. So how do we go about with it? We go by saying, what's my P bar? 0.8. 1 minus 0.8. And how many people am I looking for? 65 people. And that value, ladies and gentlemen, is 0.0496. So now we can come and answer our question. Our question, they're asking for your A value. Your A value will be 0.8. Your B value, which is your Z value, will be 1.28. And then your C is your standard error, which is 0.0496. Now D is the lower limit, and you know that the lower limit is nothing but your A, which is 0.8 minus B, 1.28 times the standard error of 0.0496, and that value is 0.7365. I hope that makes sense. So you will agree with me that for this question, all we needed is to know our formula for calculating the confidence interval for the proportion. Now we have another story for question 5. For question 5, they tell us that in a pilot study, Professor Y of the module XYZ111 took a sample of 12 students who procrastinate and recorded their mark for a 25 mark online assignment. So these were the marks of the 12 students. Now they are asking you, fill the missing numerical values for the 90% confidence interval for the population mean. Now, you know that for the population mean, we've got two cases. So the first step in this is identifying which case of the confidence interval are we working on. In this case, you will agree with me that we are working with the sigma unknown case because we are given a sample and we will need to calculate our standard deviation from the sample. And we know the formula for the confidence interval for the sigma unknown case when calculating the confidence interval for the population mean is nothing but, let's write it with a different color. It's x bar plus minus t alpha over 2, and then it is s over the root of n. So you will agree with me then that from this formula, this is your A, plus minus this is your B, this is your C. And the common mistake that I've seen in your tests is that you went and evaluated the square root, but all they are looking for is the contents of the square root, and it's the n. This is your D. Now, what you can do to find these values is you will go and plug these values on the stat mode of your calculator, and if you put these values in the stats mode of your calculator, you will see that the calculated x bar value there, when you just put them in there, will be equals to 12.4167. So you just go and put that in, and then you will see that the calculated value from the stats mode of s is it's 8. Sorry about that. That's an ugly 8. Let's write it up. 8.0052. So these are the values that we get from the stats mode. Ne? And then your sample size n, which is your sample size is 12. They said you took 12. Now the only thing that's missing is for us to find T alpha over 2. And how do we find T alpha over 2? It's the first thing we will need is alpha. What is alpha? If we are calculating the 90% confidence interval, that means our alpha will be 1 minus the confidence level of 0.9, which is 0.1. So alpha over 2 will be 0.1 divided by 2. So in short, you are looking for T of 0.05. But to find this, you will need what we call the degrees of freedom. And what are the degrees of freedom calculated as? It's the sample size minus 1. So it's 12 minus 1, which is 11. So what will I do? I'll go to my t-tables to 11 degrees of freedom, and I will look for 0.05. That is why that value is nothing but 1.796. Oh wow, now we have our answers. So you see, because we've dissected our formula very nicely, we have our A, and S was C, N was a D, and then this T alpha was our B. So we can quickly come and fill them in here. So our A to 4 decimal places is 12.4167, and then our B is 1.796, and then our C, which is our standard deviation, is 8.0052, and then our D is our sample size. It's not what we get as the square root of 12, but it is 12. And then our E, they are asking us what is the width of the interval. So how people usually do it is they go and they take the upper limit and subtract the lower limit to get the width. So to get the width. That's correct, but it's taking time because now you have to evaluate this whole thing. But if you look at the formula very well, you know that your upper limit is x bar plus this, and this whole thing here that I will circle is what we call the margin of error. So you will see we are adding the margin of error and subtracting the margin of error to x bar. So in actual essence, the width of this is just 2 times the margin of error, right? So that's the easiest thing to do. So in order to find our E, we are just going to go 2 times the margin of error. And what is the margin of error? The margin of error is nothing but your T alpha over 2 s times s over root n. So what did we call our T alpha over 2? We called our T alpha over 2 as 1.796 times s. And what is our s? It is 8.0052 all over the root of 12. So we have this and we multiply it together, and the correct answer that you will get will be 8.3008. Now we have all our answers. Again, for this question, you will agree with me, to be able to understand this question, you will need to go back to thinking, which formula am I using? I hope you're happy with that. Now, for the next question, we are asked, it's a very important theoretical question that we are asked here. They are saying, what would you recommend, if the professor wanted to decrease the width of his interval? So he wants to decrease the width of his interval. Now, if you go back to the previous question, we said the width of the interval was nothing but 2 times the margin of error. So in short, this question is saying, what should I do to decrease the margin of error? So now that means I need to know how the margin of error looks. The margin of error, we have said, looks like this: T alpha over 2, and it's S over the root of n. Now the question is, what can I do to actually decrease this? So this is what I am trying to do. I am trying to decrease my margin of error. So the question is, how do I decrease it? Now, looking at the formula of the margin of error, the first way that I can do it, maybe let's go through the answers. Do you realize, if we go from the bottom, if I decrease the mean, will this affect my margin of error? No, it won't affect my margin of error because my mean is not here. So this one is incorrect. So even this one, increasing the mean or decreasing the mean, will not help me in any way. Now, the other two is now increasing or decreasing the level of confidence. So we were dealing with a 90% confidence interval, and we found that our T alpha over 2 was equals to 1.7. You will notice that if you increase this, say, to a 95%, you will see that your T alpha over 2, sorry, I don't have the tables here, but you can check that. Your T alpha over 2 will be 2 point something something there for the 11 degrees of freedom. So in a way, increasing the level of confidence will, in actual essence, increase your margin of error. So it's not decreasing your margin of error. So that means this one is incorrect. Now you see, if this one 95% gives me a t-value of 2 point something and 90% gives me a t-value of 1.7, that means if I decrease my level of confidence, I am in actual essence decreasing my margin of error, which means I am decreasing my width. So this one is correct. Now we come to this last two. Should I increase my sample size or should I decrease my sample size? If I decrease my sample size, let's not mark this. If I decrease my sample size, check this out. Let's say I had my sample size of 12 and a sample size of 8 or 9. Do you realize what am I doing with the sample size? I am actually dividing my standard deviation with my sample size. And you will agree with me mathematically, if I divide with a smaller number, the number remains a bit big. But if I divide with a larger number, the number gets smaller. So you will agree with me that actually decreasing the sample size will inflate the margin of error. So it's incorrect. What the professor should do is increase the sample size because it will in a way shrink or make the margin of error small. So the two correct options here are A and D. I hope that makes sense. Now, for the next question, we have the following information. Oh, quite an interesting statement by a procrastinator. I'm not saying I said the statement, or did I? After all, it's only worth a few marks. It can't take that long to do. Plus, I work well under pressure. Such a funny statement that we always say, and when the pressure comes, it's not nice. Now, in a study, it was found that the time taken for a procrastinator to complete a 60-minute assignment is uniformly distributed between 42 minutes and 60 minutes. Now, suppose Professor Y now takes a random sample of 50 students who procrastinate. We define two random variables. We define X as the time in minutes that a procrastinator will procrastinate, and we define X bar as the average time in minutes that a procrastinator will actually take to complete an online assignment for a random sample of 50 procrastinators. So you will remember we covered this whole work in chapter 7. And just to take you a bit back is that now you've got two random variables, X and X bar. You need their distribution. And why is it very, very important to know their distribution is because when you're answering each question, you need to know which distribution you are working with. Now, you will remember that the time in minutes that a procrastinator takes to complete an assignment is said to follow a uniform distribution between 42 and 60 minutes. So we are given the distribution of X. So we are told, let's get a different color. We are told here that X follows a uniform distribution and the parameters are the minimum value 42 and the maximum value 60. Now the question is, what is the distribution of X bar? Now you will recall from chapter 7 that since X follows a uniform distribution, now we need to investigate a few pointers for us to find the distribution of X bar. Now the one thing that we look at is how big is our sample size. Now our sample size is 50 and 50 is greater than 30. So we can invoke the central limit theorem here to say since our sample size is greater than 30, then X bar will follow approximately a normal distribution with the mean of X bar and the variance of x bar. Now the question is, what is the mean and the variance of x bar? And you will recall from chapter 7 again that we said the mean of x bar, mu x bar, is nothing but equals to the mean of x. And in this case, they've calculated for us as 51. It's given, and you can easily calculate this using the formula for the mean of a uniform distribution. What they went to do is mean of x is nothing but, if you recall, a plus b over 2, and then to get the standard error you go b minus a all squared over 12. So that's how we got the standard error. You take the square root to get the standard error of x. Now, the mean of x bar is said to be equals to the mean of x, and you will recall also from chapter 7 that we went further to say the standard error of x bar is nothing but equals to the standard deviation of x divided by the root of the sample size. So in this case, that means the standard error of x bar will be the standard deviation of x, which is given to us as 5.1962 divided by the square root of the sample size, which is the square root of 50. Now, with that being said, I can come and say the distribution of x bar is that x bar is approximately normally distributed with mean 51 and the variance of 5.1962 divided by root 50 all squared, because we give the variance. Now we've got the distribution of x, we've got the distribution of x bar. They can throw any question at us and we'll be able to answer it. Let's go to question 7. Question 7, they are asking us, what is the probability that a randomly selected procrastinator, one procrastinator, will complete the assignment in less than 48 hours? Now you will agree with me, since we're dealing with one procrastinator. So what does dealing with one procrastinator mean? It means we are dealing with x. So we are not at x bar. So we're looking for the probability that one procrastinator will complete the assignment in less than 48 hours. And how did we say this? We said for when answering these questions, the first thing you need to do, golden rule, is you need to go and write your probability statement. So you will agree with me, we are trying to calculate the probability that x will be less than 48. Now, if we are calculating the probability that x will be less than 48, we have been told that x follows a uniform distribution. So how did we do this for a uniform distribution? You went and found your f of x. And what is your f of x for a uniform? It is a piecewise function defined as 1 over the maximum 60 minus 42, which is 1 over 18 for your x values between 42 and 60. And then it is 0 elsewhere. So the next step is that we then went on to draw. We drew this and probability density function, your PDF. We drew it and we said this is your f of x, this is your x. And we know that for your x between 42 and 60, the height of your PDF is 1 over 18 everywhere. And then we said it is 0 everywhere else. So now we are being asked, what is the probability that x will be less than 48? You will agree with me that 48 lies somewhere here. So if 48 lies somewhere here, that means less than 48, we are looking for this area. Now, if we are looking for this area, you will agree with me that then this probability statement simplifies to the probability that X is between 42 and 48. Why is that so? Because after 42 going down, that densities, the height is 0 because it is 0 everywhere else. So now how do we find that? This is a rectangle. We know the height of the rectangle is 1 over 18. Now the width of the base of the rectangle is nothing but 48 minus 42. So multiplied by the height, which is 1 over 18, and you will agree with me that to 4 decimal places this is 0.3333, and because we've got recurring threes, some of you went and gave your answers to about 5-6 decimal places. The instruction is whenever you have to round off, give your answer to 4 decimal places. So 4 threes is sufficient here. So 0.3333. I hope that helps. All right, now we can move to our next question. For our next question, we are asked to calculate the 44.5th percentile of X. But you remember, we've said this, X follows a uniform distribution between 42 and 60. And we went on to find its density, and we plotted its density and said it is 1 over 18 between 42 and 60. And then we went on to say it is 0 everywhere else. Now they are asking you for the 44th 0.5th percentile. So what the 44th.5th percentile is, it's that value, say A, such that 44.5% of the values of X are less than or equals to that value. So let's write it in a probability statement. What we mean is the probability that X will be less than that value of the percentile at a probability of 0.445. Now the quick question is, how would I have calculated this? How I would have calculated this is I would have gone to say, okay, this is a probability and it's uniform. So I would go and say, to evaluate this probability, X less than A, I would calculate it by going and saying it is A minus the width of the space times the height. A minus 42, that's the width of the base, times the height of 1 over 18. But we've just said this probability is this, so you agree with me that then that means we are saying A minus 42 all over 18, because that's what it is, times 1 over 18, that is equals to 0.445. So all I'm supposed to do to find that percentile is solve for A. Now A will be equals to, I multiply 0.445 times 18, and then I add 40, not 0.42, 42. So I'm adding 42 because I'm taking it this side. So I'm going to edit this side and edit this side. And your value for A, for your 44th percentile, will be 50.01 minutes. All right, so your 44.5th percentile for X will be 50.01. I hope we all are on track here. So all you needed to do is you need to remember what variable you're dealing with. In this case, we are dealing with X, and we have established that X follows a uniform distribution. So that is why it was easy for us to do this question. I hope we are all happy. Now let's see what the next question wants from us. Oh, now it is saying, what is the probability that the average time it takes to complete this online assessment will exceed 50. Now the question is, which variable are we dealing with? We are dealing with the average time. So in this case, you will agree with me that the average time is x bar, and we have derived in the previous question the distribution of x bar. We said x bar follows approximately a normal distribution with mean 51 and the variance of 5.1962 over root 50, but this is squared because this is the standard error. That's what it follows. Now, because we have that distribution, we can go and calculate the probability very easily. Now, but I said to you, whenever you calculate probabilities, the first step is that you will need to write your probability statement. We are asked the probability that the average time will exceed 50 minutes. Now, because we are dealing with a normal random variable, what's the next step? You will recall that the next step when dealing with a normal random variable is to standardize. So we will go, it's the probability, standardize, calculate z, it's x bar, minus the mean of x bar, divide by the standard error of x bar. Exceed, so we are going 50. What is the mean of x bar? 51. What's the standard error? 5.1962 over root 50. I hope we are happy with that. And then we know that this is the probability that z exceeds negative 1.36. So the next step is for us to see it graphically. What are they asking us? They are asking us for the probability, it's here, that z will exceed negative 1.36. So we are looking for this area greater than negative 1.36. But if you go to your Z tables, you know when you go to negative 1.36, it gives you the area going down. So how do we get this area going down? We simply use the complement rule. We know that this is equals to 1 minus the probability of Z going down less than negative 1.36. So that is equals to 1 minus, we go to negative 1.36, and that value is 0.0869. So that probability, my good people, is 0.9131. We've gotten it very easily like that. So you see here, the trick is knowing which variable you're dealing with. And which variable are you dealing with? You're dealing with x bar because they said the average. Now you know which distribution it is. It's the normal distribution. If we are dealing with x, you would have gone for the uniform distribution as the question states. Now, my good people, the end is near. We are going to do the second last question. And in the second last question, we are asked, what is the probability that the sampling error will be more than 1.25? Now, what is the sampling error? We are dealing with x bar. So you know that the sampling error is nothing but the absolute value of x bar minus the mean, right? They are saying this sampling error, what is the probability? So if we write a probability statement, what is the probability that the sampling error will be more than 1.25? Now we need to evaluate that. So we're dealing with x bar, so we do need the distribution of x bar, and we said x bar follows approximately a normal distribution. The mean is 51, and then the standard or the variance is 5.1962 all over root 50 all squared. So that's the distribution of x bar. Now, I just want to bring to your attention some relationships of absolute value inequalities. So, and these are in your notes. You will recall that there is a relationship that says if you've got x in absolute value terms being less than or equals to a, then that absolute value simplifies to x being between a, negative a, and a. So that's how it simplifies. And then the other one says if you've got x in absolute value terms being greater than or equals to a, then this one simplifies to x being greater than or equals to positive a, or x being less than or equals to negative a. And the reason this two are true is because the absolute value is a distance, right? So we are saying this, if we are looking at this, we are saying this x is within a distance of a, within a distance of a zero or from 0. So what if I were to draw it is that we've got 0, and then we've got a, and then we've got negative a. You will agree with me that the distance from 0 to negative a is a, and the distance from a to 0 or 0 to a is a. So if we are looking for this distance being less than or equals to a, it covers this part. And the moment we go to greater than, we are covering this distance are greater than a, and so are these. So that is why we will come and say it is x greater than a, or x less than negative a. So now, coming to answer this question, that means this probability statement, to remove the absolute value, will simplify to the probability that x bar minus mu will be greater than 1.25, or, which is plus, probability that x bar minus mu will be less than negative 1.25. So now what's left is for us to standardize. Remember, in the previous question we calculated z by saying x bar minus its mean divided by the standard error of x bar. Now you will see for this question that this top part is already there. What's left for us to do is divide by the standard error. So that is why here, to get our z, it's the probability that x bar minus the mean divided by the standard error is greater than 1.25 all over the standard error, which is 5.1962 over root 50, or x bar minus mu all over sigma over root n less than negative 1.25 all over 5.1962 over root 50. So now we have that. So this simplifies to the probability that z is that simplifies to the probability that z is greater than 1.70 plus the probability that z is less than negative 1.70. Now, look at this. If we draw and represent what they are asking us, we've got 0, and we are looking for the probability negative 1.70 is this area, and then positive 1.70 is this area. Now, using symmetry, we know that this area and this area are the same. So you will agree with me that I can easily just go and calculate, because I know Z tables give me lower tail probability. Calculate the probability that Z is less than negative 1.70 and just multiply it by 2 to get this one. So which is equals to 2 times 1.70, which is this area of 0.0446. That gives us an answer of 0.0892. Quite easily done. So all you need to know when they're asking you about the sampling error, you just need to know these two lovely inequality relationships. All right, good people, now we can do the last question. For the last question, we are asked, it is known that 2.5% of the times the average time. Okay, we don't even need to read further now. Before we can continue, we know that we are dealing with the average. So which variable are we dealing with? We're dealing with x bar. So what do I need? I need the distribution of x bar very quickly. For myself, x bar follows approximately a normal distribution, mean 51, and then the variance is 5.1962 divided by the root of 50, all squared here. Just remember, we give the variance, not the standard error. So now, with that being said, we can read the question now. They are saying the average time it takes to complete an online assignment is more than R. More than R, 2.5% of the time. So the key word here is the more. It's more than R, 2.5% of the time. Now, please, NB, read the question. This time I'm giving you an instruction and I'm saying don't use tables. Use Excel to calculate the value of R. And you will remember in the lectures, we actually say these instructions are important because you will see there is a rounding discrepancy between Excel and using the tables. Excel uses the full Z value while the table use rounded Z values. So please just take note. Whenever we say do your calculation on Excel, don't go and do it using your tables. Whenever the instruction is use your tables and only your tables, and this was the in main instruction for this test, that use your tables unless I ask otherwise. In this case, we are on the otherwise. I say use Excel. Now, but before we use Excel, we need to go back to our theory. We are being told, so what I do when I'm faced with such questions, I usually represent it in a graph. So in a graph, I know I have my mean of 51. Yes. So because I haven't gone to Z, I'm looking for the time, the average time. So it's X bar. So I'm dealing with X bar. So, and the mean is 51 there. And I'm saying to you, 2.5% of the times, this average time will be more than R. So I can't have R anywhere in the less than 51 region. So definitely R will be here. Why is R here? Because I said R going up more than R should be covered by an area of 2.5%. That's what I'm saying. So you need to see it visually. So you realize what the question is saying is that the average time is more than R 2.5% of the times, more than, so it's greater than R 2.5% of the time. So if we were to write it in a probability statement, we are looking for the probability that X bar will be greater than R, and that probability is 0.0892. 0.025. Now, you will agree with me that in your tables, just like in Excel, we actually get lower tail probabilities, not upper tail probabilities. So if we need to find lower tail probabilities, we use the complement rule. So we know by the complement rule, 2.5% going up is 97.5% going down. So that is why this probability statement, if we want to write it in a way that we can read it off from the tables or in order to find R, or we can use Excel, which also use the cumulative function, so it also gives you probabilities going down. We need to change this and say this probability that X is less than going down, R should be equals to 0.975. That is why on the tables then we would go and look for 0.975, and then we will actually put it in terms of Z and then bring it back to X. But now we go straight to Excel. So now we know that in Excel this is somewhat a percentile question. So what it means is that I will need to then go and write it in an Excel function. And to calculate a percentile in Excel, we use what we call the norm.inv function. And you know, for the norm.inv function, what it will ask for is the parameters there will be the percentage, and then it will ask for the mean, and then it will ask for the standard deviation. Are you happy with this? I hope you are. Okay, maybe our bracket, let's have it in our purple color. So these are the parameters. So now we can come and put in our values. So that means to get this R, we can go and say R is equals to, or rather, let's not put this. We know when we go in Excel, we start with an equal sign, and then we put in norm.inv, and we know our percentage in this case is 0.975, and our mean is 51, and our standard deviation is nothing but 5.1962, but it is divided by the square root, so SQRT of 50. I just always, then we can close our bracket. There you go. Now you will see when you press equal here, this answer that you will get is, it will give you 52.4403. So now you've used Excel. So that is why we always suggest when you're using the tables, you can just go check your answers using Excel. So just a quick summary. From question 7 to question 11, you will realize what was important was getting to know which variable between these two are you working with. Are you working with X or are you working with X bar? And if you're working with X, what is the distribution of X? Because you know the distribution of X, you were unstoppable. You go to X bar if you asked question on the average, because you know the distribution of X bar, you're unstoppable. So that's the key here. You just need to know which variable you're dealing with, thus which distribution you're dealing with. So that brings us to the end of the test. Thank you for watching this video, and I hope while we are at it, we will get to acknowledge that sometimes we do procrastinate. And as you can see here, I've given you the phases or the steps that are involved when you procrastinate. And the funny thing is that when we get to the crisis mode, we actually tell ourselves, I am never doing this again, until we get back to thinking we have the time, or getting back to being brought closer by the sweet nectar of procrastination. Because once you taste it once, you won't be able to stop. So let's try and fight procrastinating. It is sweet, but it leads to crisis. Thank you very much.